How's it going, people? Okay, so this is what we were looking at last night. See, the type info for this says it's signed. So we were looking at 2 to the 63 minus 1, right? And this number is 1 more than that. Or, wait, this one's got a minus now. Oh! Wait, it had a minus the whole time. Okay, I know what the bug is. The bug is our integer parsing. Our integer parsing tries to parse as a positive number and minusing it at the end if there was a minus sign. And the problem with that is there is a negative number that does not have a positive equivalent. And if your input happens to be that number, okay. So see, it's good that I went to bed and woke up and looked at this because it's much more obvious now. So yeah, like you can't do positive this number, but you could do negative this number. So we could no AOC it, or we could, in the loop, we could have a separate loop. So, oh, hold on. This is going to be the movers. Okay. Movers are going to show up. Maybe. Maybe. So one thing, see, here's what we do, is if it starts with a minus sign, we set a multiplier of -1, okay? And the problem is, right, and then we treat it as a positive number. We could have a different loop, or we could have a sign multiplier. Basically, we could subtract each digit and multiply by minus 10, right? Is that better? I don't think it's better because it's probably slightly slower, because we'd be multiplying by, minus. Minus times the digit. So I'm just going to no AOC it and put a comment. Okay. The problem is, see, I had this comment here, we should probably check for overflows. We probably should. And so for that reason, maybe we should do it the right way. What is the... Let's... So here's the thing. Oh, yeah. I needed to remind myself that we have this punctuation here. I was like, can we do all this in one range? No. No. But that's not relevant to what we're even thinking about. Okay. I mean, I'm tempted to put the extra multiply in. which kind of is ass. Let's try it this way. Signed base is base. Oh, well, yeah, we only do this if the input type is signed anyway. So maybe it's not so bad. I don't know. Oh, wait. This isn't going to work. Let's just do it without thinking too hard at first. So okay. Now, basically, why do I do this run twice? It's annoying. Okay, so this is very small change. Right, so now it's like, all right. Let's see if I messed everything up real bad. Okay. That was some loud noises. All right, well, this is a different issue. So let's see what that is. Let me put the comment here about why. Might be a little slower than max speed because we multiply by sign for each digit. The reason is we originally, our original approach did not do this, but rather we just accumulated into an unsigned, or into a positive value and then negated at the end if we saw a minus. But this does not let us parse the maximum negative number without overflowing positive number, which works if you are not doing arithmetic bounds checks. We could have done no ABC on this procedure, but I decided it's worthwhile to just try the clean version to try to preserve the ability to report genuine overflows. So I did the clean version here. Okay, so we got to run from here because we want to see it's probably another hash function. That's what it looks like, but who knows? Get light strobe. It's a random number. Yeah, like literally, these are the two cases in programming when we want to do this. Array bounds check fit. Whoa, what? Fog volume index. This is a problem. Because this is not anything to do with what we're working on. Why there's so many? Bro. So do we add... Let me see if anyone put in an update for this. Because I could put in a workaround for it, but it's better if I don't have to. Guys, I literally wrote the comment explaining what I did. Was the comment not clear? Do you see the words that are coming out of my mouth? Well, that didn't get fixed. High security mode for a second. Okay. So I have to work around this to continue. Where is this defined? Where? I can't type. Okay. Max fog volumes. 255. Okay. If fog volume index is greater than to max fog volumes, log error too many fog volumes. Break. This has to go below here, of course. Okay. Where was that? Fog of war. Too many fog volumes. Oh my god, it's literally every frame. What? Okay, everything is totally fucked. So I think I broke the integer loading. Because this map is... This map is making me unhappy. Okay, so... We're just finding them one by one. Yep. So the wall sets are all messed up, which means I broke integer loading, which is sad. I'm amazed the game runs at all, given that, but we're going to have to fix it. Well, I don't know what to do. Why don't I just keep eating seaweed snacks instead of programming? How about that? Yeah, well, clearly this needs to be improved. Oh, guys, I just haphazardly in my brain said multiply by minus 10. That's fucking stupid. Because then you're toggling the thing, you're toggling the sign of the thing for every digit, okay? That is not how to do it. You just do the other one. You just do the sign times value, okay? Which that's good because then we can get rid of signed base. We can be more based. Okay. Hey, look. It makes sense now. The map actually looks like the map. Wait. Okay. Okay, so that fog volume bug was triggered by something else. It looks like this was being triggered by a different newly introduced bug and has gone away. Was fixed. Nevertheless, I put a check in that loop so that it does not overwrite the buffer. since we don't want that kind of thing to happen in response to random user content changes, e.g. adds a bunch more fogs to the map. Okay. Cool. Well, this is pretty promising. One thing we could do, are we in debugger? Yeah. We could start running a Benny test. Okay, well that was fast. Remap vertex colors. Really? See, this is why we put these checks in. Because, like, holy crap. X1, Y1, Z1. The fuck? Cell count. X. Okay, so this this is something wacky times 900. The 900 is coming from here. So this is like Z is something wacky. Oh shit. Z. Oh, Z not. The fuck? Okay, so cell count over size. Has fucking infinity. Bound size is 0. Okay, I'm going to delegate this now. I mean, I guess this means we're not throwing on divide by 0. Which obviously that can be a check as well, but I would think that we would be throwing a float exception. But I don't know. I don't know what the defaults are for that in a Windows executable. I mean, no, it's literally 0. It is literally exactly 0. Okay. I will go into high security mode. In this case, bound size dot z equals 0. We divide by 0. So cell count over size dot z is infinity. Which makes Z0 and Z1 super big negative numbers. The overflow was caught with the new checking when doing the multiply to compute cell index. However, I suppose this also highlights that we are not trapping float divides by 0. We probably should be, but oops, something went wrong. My Gmail just said, oops, something went wrong. Great. We probably should be. I'm not sure if the best way to do that is to turn on the float exceptions at startup, since these can be arbitrarily turned off later by random code you call and you wouldn't know, or to check float divides in debug builds the way we are doing for other integer operations now. Okay. So that has gone out. Yeah, how come people don't ship like really dark mode? Okay. If Donnie Darko Dark. All right, we are Benny testing with arithmetic bounds checks. All right, I'm going to check that workaround in. Workaround for the divide by 0. Temporary. This should get fixed for real. I'm kind of surprised. Okay, so here's the thing. Let me turn down the game sounds. Here's the thing. When we're implementing stuff like these bounds checks, there's always a trade-off. There's like, how much benefit do you actually get from the checks, right? And how much inconvenience do you have to go through from things that were actually fine, right? Now, we went through our code base, and most of the things that we fixed were actually fine. I think there were 2 legit bugs, right? And one of them was that divide by zero, which would have been caught by like divide by zero checking. Although that might, divide by zero checking may just be considered a subset of what we're doing, maybe. So maybe we only caught one legit bug or maybe 2 legit bugs, depending on what you think. In a game this big, that isn't very much, right? And so maybe it's worse and more annoying to have to go do hash table stuff every time. Like every time you have a hash function or whatever, you have to do stuff. I don't actually know. You're a firm believer in the latter. What's the latter? Because I'm not sure it's worth it. Like, it is sort of an experiment to have these bounds checks in this compiler. And the reason that motivated me to put them in finally, because they've been vaguely on the roadmap for a long time, but the reason was that one of the beta users ran into problems and didn't understand what was going on. And, it was like multiplying 2 numbers that don't fit in an S16 or whatever. And so I was like, okay, let me get this off the list and put it in. So that's been fine. It's just, I'm not sure it's catching that many legit bugs. But that said, for the legit bugs that it does catch, would you have found those any other way? Or you would have eventually. Like, how long would it take you to find them? Etc. Yeah, so I'm not sure. I am not sure. The jury is out on whether these are a good idea. I found the divide by zero bug? No, the compiler found the divide by zero bug. That bug's been in the game for like a year and a half and nobody knew. Language safety purists, but that doesn't matter. Like, if the language safety purists are freaking out about something that doesn't matter, like, I'm not actually interested in appeasing people like that because I'm doing things that are reality based, right? And we already know a lot of those people are not reality based. So I'm not honestly that worried about it. Yeah, I mean, I think what I'm going to do, so in the short term, there's a policy decision to make, which is, do we turn these on by default in debug builds or not, right? And the upside of that is we might catch more bugs for more people. The downside is whenever people have hash functions or whatever, they're going to have to do something with them. That said, we already tweaked all the standard hash functions, so it's really just whatever people would have ad hoc in their own code. Yeah, I'm not sure. I mean, I worked hard for several days to make this happen, so it would be a bummer to not enable it, but it's only a few days, right? I need to make a note about the beams over water. Not looking good. Okay. So overflow check discussion we need to do, and beams over water. Well, it does seem like, though this is done to a first approximation, like we have an entire video game running. with these checks in, and they're going fine. I don't know what the fuck's going on in that level. I'm going to screenshot these level names. See if we could figure it out. Okay, I'm going to consider this enough of a Benny test, though. So let's just, let's try editing. Pop and open a color panel. Undoing. Redoing. I mean, there could be some bounds checks fails remaining. You know, there's quite a few. Why are we going so fast? The fuck? Why do you think that's the right speed? That doesn't remotely look... What is going on? That is not a good animation. Maybe it's just that one is hosed? Maybe the animation loading is busted, although it should be binary now. Let me see if this is busted, like... in the release. Oh! It's busted because it's using the clock from the... never mind. It's using the clock from the Benny test. Is what's happening. Yeah. Yep. Anyway, there could be more bounds check fails, but I think we would find them over time. So I think I'm going to go here. We can enable this if we want overflow checks. All right, so this is don't enable these by default yet. Okay. We're going to off by default. But they're in the compiler for people who want them. By default, no AOC things that need it. Okay. Commit. Okay. Is there a point in having an annotation to mark intended overflow? Yeah, I mean, that's sort of the converse of what we have now. And we have something like that on casts. And so we could put that on operators. That would be a thing we could do. Simulate still had a no AOC. Yeah, we're checking in all the no AOCs because I'm not turning this off or taking it out. I'm just not having it be on by default. But we want to still be able to compile with bounds checks. Because part of what I want to do is like evaluate how useful are these over time, right? So there's a few other things, like we could try compiling all the tests with bounds checks. We could try what else? Well, we can make all the specific bounds checking tests. That is what I said yesterday was we would do that when we have it done in all the backends. And theoretically, it's done in all the backends now. So that is a thing that could happen. Because I'm yawning, I think this might be a good time to have made it a short stream and I can go continue to wake up. Although maybe I should have some ice cream for breakfast. What are there any questions about what we've been doing today? Like deeper questions that I can answer while I have ice cream for breakfast? We've got a mint chocolate chip ice cream here. 13-year-old me would be proud. Maybe. I mean, I think 13-year-old me would not understand what all this stuff is and like would have actually no idea how much has been done here to make all this work. So 13-year-old me might be proud, but also would not be capable of fully appreciating what has occurred. Uh-oh, the freezer's beeping because I left it slightly open while I'm getting my ice cream. Are there explicit modulo arithmetic operators to complement range checks? No. No, you just turn off the range checks. Or like we literally just said, you would annotate, you would put a modifier on them if you want that behavior. Is Sokoban going to be playable on Mac? I don't know. I mean, not that many people buy games on Macs. At the same time, though, it is non-zero. It's like maybe 10% of our Steam sales, which is substantial. So we'll probably do it, maybe. what if there's an overflow in some library code that you don't have? Then that library code is wrong. I mean, what if there's any bug in some library code that you don't have access to? Oh, you mean like a precompiled C program. This is not going to affect that. This is only for code generated by this compiler. So it's only for, things that you're actually compiling. Is there a plan to drop LLVM? Probably. I mean, the thing is, LLVM is still useful for targeting other architectures, right? So we would probably keep it there for a while, but it would definitely be, the plan initially is to get it no longer to be the thing that you would use to generate a release build, right? To generate optimized code on x64. We are using the LLVM C++ API. How many platforms do I realistically want to target? I don't know. Let's say the lifetime of this programming language is 50 years. How many platforms are there going to be in 50 years? That's how many. Right now, no AOC goes on any block. It's like a block decoration. And it probably would be useful, though, to be able to put it on an operator or put something on an operator. Some sort of interface to reduce the common code between the two backends to eventually provide the groundwork for other custom backends. I mean, that's mostly there. There's not a ton of copy-pasted code between the backends. Like if you were to add another backend, you would pretty straightforwardly just do it today. You wonder why Zig wants to get a custom backend? You can read his posting about it. It's pretty clear. It's pretty clear. Is it a lot of extra work to generate optimized code without LLVM relative to how much work has already been done to make the custom x64 backend? I mean, it's hard to answer because because optimization, so the answer is it's probably more work. But optimization is a sliding scale, right? It's not like it's all or none. It's more like there are some optimizations that you're going to get a large benefit from. And then a long tail of other optimizations you're not going to get as much benefit from. But that if you add them together, it may be enough to really matter, right? And so the question is really, how far out on the curve do you go? And, well, you know, the plan is we start by not very far and then increase that over time. And so if the question is how much to get parity with LLVM's output, I don't really know. I mean, LLVM does a lot of crazy things like auto vectorization and whatever that may or may not actually help with good code. Like, part of the thing to realize is that all these optimizations that LLVM and GCC have built in, they're tuned for like complete shit code, right? Which is why like the inlining is mega, mega, mega aggressive, because it's written for these code bases with like 17 levels of getter setters and all this stuff. So if you were to calibrate optimizations for a different programming style that's less unreasonable, what do you get? Like, I don't know. And so we just have to see. When I first started doing this compiler, I tried out putting text IR, and it was a complete disaster. Like, I would give it to whatever tool, you know, to generate binary from it or whatever, and it would just crash because it didn't like what it was parsing. It was complete shit. I just gave up on it. Any other questions about all the things? I'm almost done with my ice cream, which maybe means we're almost done with the stream. This is weird. Our defaults don't match. That's not good. All right, everybody. Time for me to sign off for now. Thank you. Have a good July 4th. Go shoot some guns. Etc. Have a good night.